I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 14. We are in our hot and cold unit. Cheryl,
Yes.
what hot and cold question do you have today?
Oh, I have a fun one. It's going to be a party, Ryan.
I enjoy parties,
Yay!
but not as much as you.
So I was thinking back, I was reflecting earlier on what I remembered from science class. And then I was thinking back a little bit more just on what else do I remember from school? And one thing that I remember from school was the Halloween parties, because they did the fun snacks that you got in school, and you got to wear a costume to school, which was so fun and unique, But then if you were lucky, your teacher arranged it to have punch. And I mean, what kid doesn't like punch? Because usually it involves sherbet and 7-Up, which is wonderful. But then on Halloween, it also involved dry ice, which is witch's brew punch.
Right.
The best. And it also seems magical. You're like,
for
how
sure.
is this smoke coming out of this punch bowl? And also, why is it okay that I'm drinking it? But I'm a child, so I'm going to be drinking it.
Sure.
And now I know how to make punch, but I still don't actually know what dry ice is. So that's my question today. What is dry ice?
Oh, what is dry ice?
Yeah.
Okay. All right. That's a good question. I think that's something that a lot of people have encountered and had similar experiences to what you have.
Totally.
But I really do wonder how much people know about dry ice now that you mention it.
Yeah. Well, I have to say, even asking this, it's definitely one of the topics that's making me feel a little extra stupid, because, we always do this pre-assessment, and I have thoughts about it, or I have an idea of whatever we're talking about might be. And with this one, this is the one I feel the least knowledgeable about, the least comfortable asking, because I'm I'm feeling a little extra dumb right now.
Well, first of all, you shouldn't feel dumb.
It's a relief.
I know. And me saying that solves it completely. Now you don't ever feel dumb ever again, right? That's definitely the way that works. No, but I think something that is pretty common, and as a teacher, I run into this in my classroom. We often feel dumb about things. I don't understand this. And then we don't ask the question. And then when we don't have the question, we never learn the thing, because we feel like we should know it when we don't.
Yes.
And while there are certain instances where there are certain things that we probably should know, most of the time, they're not really. I doubt that any of your teachers who made you witch's brew taught you about dry ice.
Yeah, probably not. I don't think I slept through that.
Probably not.
Yeah.
And dry ice is not a standard topic that you cover in a chemistry class, for example. It's a cool application of a lot of things, but it's not something that you would necessarily directly have a lesson on dry ice unless the teacher wanted to. So the fact that you don't know is not a bad thing. And the fact that you're willing to ask the question is what, for me as a teacher, I love that, because you're going to learn. And if you don't ask, you're not going to learn.
That's so true. Yeah. And I mean, I think, again, that's why we're doing this podcast, is because I'm guessing there are other people who don't know what dry ice is.
Oh, I guarantee you.
Might feel embarrassed to say, what is dry ice?
Yeah, absolutely. Well, we are going to start with the pre-assessment. And I know you already said you're not quite sure what even things you know. So I will do my best to kind of guide you, instead of just what do you know. I'll kind of ask you some more specific questions to kind of tease out. Because one of the other things that we've seen on this podcast so far, and that I've experienced before, we often know more than we realize we know. But when we run into something that we don't know a lot about, oftentimes our brains just go, oh, I don't know. And then they shut down and they stop processing.
Yes, totally.
And so what I'm going to try and do is try and pick at those things to try and help you uncover the components that you do already know. And then we can build on those and add to the stuff that you don't.
That sounds great.
Okay. So let's start with this. Can you tell me anything about the temperature of dry ice?
I'm going to say it's cold because I feel like I've seen it in a cooler.
Okay.
Like it's like brought in a cooler.
Okay.
And also I feel like it would be cold because if you're putting it in punch, like then the punch isn't warm after that.
Okay.
Yeah.
If you were to compare dry ice and just observations you've made about it to normal ice, I'm putting that in quotes, but what as a science person I would call water ice, what would be some things that you say might be similar and what might be different?
Well, we call both of them ice, so that's a similarity.
Great. Yes.
I think they're both cold. I know that water ice is cold. I think dry ice is cold too. I know that I think you're supposed to be careful with dry ice, which also makes me think it's like really cold if you're supposed to be careful. Cause like, not that you would want to hold an ice cube either. And we talked about that before of like, why does it hurt when you touch something really cold? But then I wonder, like, are you supposed to be careful of dry ice because it's like actually could give you like frostbite or something like that, like the cold version of a burn or something. And I would say the differences are that dry ice smokes, or I don't know if smoke is the actual thing that it is, but it looks like smoke. I actually probably think it's not smoke, but it looks smoky or steamy. Maybe closer to steam than to smoke. So if it's steam, then does that mean that it's becoming a gas? I wonder if it's going from solid form to gas form at room temperature. And that we're seeing the steam like you'd see a pot of water boiling. Those are my guesses.
Okay.
Yeah.
You've got a lot there for me to work on. So
really?
Yeah, you have a lot of really good information. Like I said, you know more than you realize that you know.
That's so exciting.
It is. We're going to break this into two parts, I think, Cheryl. I'm going to start with just what is dry ice, just like the substance itself. And then we're going to build and we'll talk about what does dry ice do.
All right. That sounds good.
Like, why does it make punch?
Why does it make punch? Why is it delicious?
Why is it? Well, yeah, sure. So the first thing is, what is dry ice? And this might be a surprise to you. It's carbon dioxide.
Oh, I am surprised to hear that. I was wondering if it was actually ice, but I'm surprised to hear that. Yeah.
So the interesting thing is, in science, when we use the word ice, it's a little bit different than when we use the word ice in everyday conversation. You may be hearing a theme develop here as we have different lessons. So when we say ice in everyday conversation, what substance are we usually talking about?
Water ice.
Exactly, water. Whereas like in science, we'll talk about a lot of things as ice or ices if they're frozen.
Okay.
So if you remember back to an earlier lesson when we talked about things freezing, you gave an example of something that's with you that's frozen right now.
My desk.
Your desk.
Yes.
We could say that your desk is desk ice if we wanted to. Or I guess wood ice. Maybe it's made out of wood. It's not exactly the same thing, but it's a similar idea, right? Because it's frozen. So dry ice is carbon dioxide that's frozen. It's in the solid state.
But okay, like I have a question forming and then it's like being answered as I think about it.
Okay.
Because I want to say, like, how can carbon dioxide freeze? Because it's a gas, but a gas can become a liquid, can become a solid.
Correct. And what do we do to a gas to turn it into a liquid or into a solid?
freeze it.
But
Put it in a lower temperature.
A lower temperature. We have to lower its temperature. Yes. Exactly. And so carbon dioxide at normal room temperatures, not even at normal room temperatures, just at all normal Earth temperatures, carbon dioxide is a gas. Even down at Antarctica, carbon dioxide is a gas.
Oh, that's a good point, because if you're breathing out in Antarctica, you're not going to breathe out like
a liquid or a solid.
Yeah.
Nope.
That would be alarming, though, if that was the case.
Cause major issues to your body.
Oh, that's a very good point. Yeah. Okay. Yeah.
So what you have to do is you have to bring the temperature down artificially to get it to actually solidify or freeze, turn into a solid. And I don't have this memorized. I looked it up. But the temperature, in case you're wondering, what do you want to guess? How cold do you have to make it?
Ooh. -200 Fahrenheit.
That's a good guess.
Do you want a Celsius guess?
Nope. Fahrenheit's totally fine.
Okay.
That's a good guess. Doesn't have to be quite that cold.
Okay.
It's -109 degrees Fahrenheit.
Wow. That is very cold, though.
Which is, -78.5 degrees Celsius. So
if I were suddenly in that cold of temperature, is that the reason I would die, or would there be another reason that would kill me first?
There would be multiple reasons that you would die. I'm not sure. Depending on why you were in that temperature, like were you submerged in something that's that temperature, like what was going on? There could be a lot of factors that would kill you.
Okay.
But that is definitely one of them that it could be, is because carbon dioxide isn't just in the air you breathe out. It's also like in the air, technically, when you breathe in as well. Think about all the discussions around climate change and things. We're putting more and more carbon dioxide into the air, which means it's there.
Yeah.
Right. And so if it's cold enough for it to turn into a solid, that means it's going to turn into a solid from the air.
Wow.
That's very cold.
Wow. That is very cold. Interesting.
Yeah. So one of the other things that you mentioned was that you thought it might be dangerous.
I mean, yeah. And now I feel like I'm right.
You are definitely right, because it is so cold. And like you said, ice, if you put ice just directly on your skin for too long, water ice, it can hurt and cause some damage.
Yeah.
This is way colder than that. And so, yes, anytime you handle dry ice, usually they recommend you wear gloves or you don't touch it directly, because it is so cold. If you remember when we talked about heat and moving thermal energy, and we talked about how something that we feel is cold is really just the heat leaving your body. Does that sound familiar?
Yes.
Same thing for this, but it's so cold, the heat leaves really, really fast. And
that makes sense.
And it can leave so fast that your cells, which are mostly made of water, can freeze.
Ooh.
Because water freezes at 32 degrees Fahrenheit or at 0 degrees Celsius, and this is way below that. So if you put water in contact with dry ice, it's going to freeze the water. And since we are made of a lot of water.
Oh, no.
And that's basically what frostbite is you've frozen your cells. Yeah. It's a little more complicated than that, but you can basically think of it as you've frozen your cells. You've killed the cells because you've pulled all the heat out of them, and they've frozen. The liquid in them has frozen.
Yikes.
Yikes.
And so let's bring that into a classroom full of children for a party. Great. Glad I'm still here.
You just don't let them touch it. The reality is, and this is not something I'm going to recommend everybody go and do. You can, if you have a small piece of dry ice, you can touch it for very brief moments of time, as long as it's a very light touch. Like I've held a piece of dry ice in my hand. I just kind of shake my hand around. So it's not like sitting on my hand for multiple seconds or minutes. I'm just kind of moving it around. So for a short period of time, you can do that, and it's not going to cause frostbite or a burn or anything like that. Okay. But it's still pretty dangerous, and you wouldn't want to just, say, here, you kids, go play with that.
Yeah.
As a matter of fact, at least in Washington State, and I don't know if this is across the country or not, you have to be at least 18 in order to buy dry ice.
That feels okay with me. I
Yeah.
think I'm okay with that.
Yeah. I think that's reasonable. The other thing that's interesting about dry ice is the dry part of it.
Yeah.
Because and you mentioned this, you said it lets off the smoke that you didn't think maybe was smoke. And we'll talk about that. That's our second part that we'll talk about in a minute.
Okay.
But dry ice does something very, very interesting. It skips a phase.
Liquid.
Yeah. It
Because
doesn't melt.
because the temperature is so drastically different that it just like jumps past it.
It's for more complicated reasons than that. It has to do with its chemistry and some things like that. It's not
Okay.
normal for substances to skip a phase.
Oh. Okay.
Under normal like earth conditions, it's not normal. You can force that to happen, but there's actually a fancy word of going from a solid directly to a gas, which is what dry ice does. It's not melting because it's not turning into a liquid. It's called sublimating.
Sublimating.
Yeah, it sublimates.
Interesting.
Not something we typically hear, or a term I think that you use all that often.
It's kind of like when a baby skips crawling and goes straight to walking. It actually like concerns people when babies do that. But I'm just gonna call that sublimating now.
There you go. Oh my gosh, your baby just sublimated. We need to worry about that one. Yeah, so it's skipping it, and that's where the dry part of dry ice comes in, because if you just leave a block of dry ice sitting on the counter, it will get smaller and smaller and smaller, and there will be nothing left. There will not be a puddle of water or liquid
Wow.
of any kind,
Wow.
which is cool.
And it's very good at cooling down punch.
It is very cool of cooling down punch because, again, it's transferring that heat
So you
very, very
could put
quickly.
you could just keep your 7-Up on the counter before the party and put it in the bowl and you'd be fine.
Yes, you would.
Wow.
Yes. And there's an extra thing that it does as well, but let's talk about that smoke. Let's do that second part.
Okay.
And then I'll talk one more thing. We'll end with a cool party trick that kind of goes with it that you may
Nice.
not have noticed.
Sounds good.
Okay. So you're right that the smoke isn't actually smoke.
Yeah,
Smoke
because
is
it's
usually from
not
things that are
burning.
exactly. Yep. It's not smoke. And you were even thinking back to a previous experience. You talked about, well, maybe it's more like steam.
Yes, and now I'm wondering, is it steam or is it water vapor? Because steam and water vapor are different, Ryan.
Well, yes, they can be for sure. And you are exactly right. Remember when I said you knew more than you realized you did?
Heyo.
Because you're right. What you're actually seeing, that smoke or steam, isn't actually carbon dioxide. It's water.
Why?
Because it's so cold so the bubbles that form, those bubbles are carbon dioxide. But then when they reach the air, it's so cold that anytime it gets near water in the air, the water condenses, or even maybe a little bit freezes. And so it's actually water vapor that you can see, or it's condensed into the liquid in little tiny pieces, just like steam. It's just much more concentrated because it's so much colder. It can do it to more of the water that's in the air.
Interesting. Okay, so when it becomes a gas from its
Mm-hmm.
solid form,
Mm-hmm.
you don't actually see it in the
Correct.
air as
You do
it's
not see the
becoming a
carbon
gas.
dioxide. Correct.
So if it were like you mentioned, if you just like let it sit out and it gets smaller and smaller, when it's not touching water, it would just get smaller and smaller and it would just look like it was shrinking without seeing
Mm-hmm.
stuff in the air.
Mm-hmm. If there was no water vapor in the air at all, which you're never going to encounter here on Earth.
Oh, okay. So you will still see something, but that something is the water vapor in the air.
Right.
But like if it were in Florida, you might see more than like Arizona.
Potentially. Yeah, I've not tried that, but potentially, maybe.
Interesting.
Yeah.
I didn't see that one coming.
Surprise.
That's fun.
It is kind of fun. It is fun.
Yeah.
And that also means it's perfectly safe to inhale. Like it's not going to hurt you or anything. It's just water vapor.
Yeah.
Or condensed water, right? Because we can see it. So
cool.
yeah, I think it's cool anyway. I agree.
Nice.
Yeah. So that's what that is. The last little bonus thing.
Party trick. Party trick.
And if you're putting it in 7-Up, you're not going to notice. But if you
7-Up has bubbles.
Because 7-Up already has bubbles.
Okay.
What are those bubbles?
Carbon dioxide?
Well, when we say that soda is
carbonated.
Carbon
dioxide bubbles.
It's carbon dioxide.
Which I'm going to be asking you about in a future episode, because how did those get there? We're going to need to talk about it sometime.
Perfect. That's a great thing for a future lesson. But yeah, carbonated soda or anything that's carbonated has carbon dioxide dissolved into the liquid. And so when you put dry ice into a liquid, it carbonates it.
Okay, so then if you want to do that fun thing, you would do like juice instead of a soda.
Yep. And you can do it in the soda. You're just not going to notice it as much. But I've done it even just in plain water, and you leave it for a few minutes and then you take a drink of the water and it tastes like carbonated water, like bubbly water. It does. It just doesn't have the flavors in it. Yeah.
Wow.
It has that slightly bitter flavor to it.
That's fun.
Mm-hmm.
Well, we'll have to do that sometime.
We will have to do that sometime. Yes. Okay. So that's dry ice. That's what it is. That's sort of how it works. Does that answer your question?
Yes.
You feel fully confident now in what dry ice is?
Ooh, I don't know about for that pop quiz, but we'll see.
Speaking of pop quiz, are you ready for the first question?
Maybe. We'll find out.
What is dry ice made of?
Carbon dioxide.
See, you were ready for the first question. Nice job.
Yay!
Next question. Why is dry ice considered dry?
Because it skips the liquid phase when being heated up, essentially. It goes straight from solid to gas.
Wonderful. And this is very similar. What is unique about dry ice's phase change?
It skips one.
Mm-hmm. Do you remember what it's called? What we call that?
Oh no, I already forgot.
Do you remember any part of the word?
I feel like it starts with a V. Oh no, it doesn't say. An S. An S. Does it start with an S?
It does start with an S.
Syndrome. I just watched The Incredibles. I know it's not that. Sublimation.
Almost, actually. Almost. Sublimate.
Okay, we got there.
Yeah.
With significant help.
Well, that's okay. And the last question. What are the clouds made of?
Water. Vapor / condensed water.
Mm-hmm.
Yes.
As a matter of fact, I think cloud is a really good word to use for it, because that's what clouds are made of.
Cute. Okay. I like that.
So you are actually making clouds.
Oh, that's lovely. Now I want to go get some dry ice. I better go head over to an elementary school's Halloween party.
I mean, that's one place to get it, or you could get it from one of the, where the teacher probably got it, which is a grocery store.
You can buy it at the grocery store?
That's where I buy it from when I go get it.
You didn't teach me that part. That's the most amazing part about dry ice.
Yeah. We have a store here in this area called Fred Meyer, and that's where I usually go to get it. Sometimes you can get, not all grocery stores have them, but typically you can go, if you go to the meat or seafood department, they often have it there because it helps keep all of their meats and seafood extra cold.
Okay.
That's often where you can do it. I would call them ahead of time. But there are some places that also just sell straight up dry ice as well. I
could just go buy dry ice whenever I want.
As long as they have it in stock. Yeah, I just did it a couple weeks ago.
The dream. That is the dream. Okay, great. I like being an adult.
You're welcome. That's all the time we have for today. So why don't you pack up your stuff and get ready for my closing remarks? You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.